Hey, morning, everybody. Thanks for coming. I'm Tony Andrews with Themis. We're a training and consulting company, like more training than consulting. I've been doing quite a bit of mix over the years. I come from the development side. Kind of been an application DBA from time to time, but I'm a developer at heart, and I'm very passionate about a lot of things that I get to talking about. This is one of my favorite topics right here. I do a lot of performance and tuning consulting, where companies will bring me in and we'll help them figure out how to get things to run faster. I would say probably 85% of the time, all I do is restructure people's queries and redesign their programs. I rewrite their code. The other 15% of the time we spend on like some indexing and some run stats and some other things that can have an effect on performance and tuning. So I do a lot of developer subjects and areas, SQL, advanced SQL, performance and tuning. So that's what this one's about. You know, what do you do to get these things to run fast, some of these programs, some of these queries? You know, what do you do? Well, one of the things that I'm real big on, I've been on a lot of big projects, vSAM to DB2, IMS to DB2, Datacom to DB2, you name it to DB2. I've written lots of programs and lots of queries, and I got like really good at this. But what I found over the years in being a developer in some of these projects and helping to run some of these projects is I'm really big on standards and guidelines. I'm really big on examples out there. I'm really big on empowering the developers, okay? Getting them to know how to read explains, getting them stronger in SQL, because that's where most of the problems come from in my experience. I mean, think about it. 85% of the time, I go in to get things to run faster. I never talk to a DBA. I'm over in the application group. So as I go from company to company and I get out there and I start looking at the code and the problems of what's going on, most of the time I can get things fixed in the application code. So then we go in and have meetings and we go, why am I seeing this stuff in production? I don't see any standards. I see very few guidelines. I don't see any documentation on a shared drive out there for developers. We need to start getting your group educated. We need to empower them more. They say, well, a lot of shops go, well, we don't have time for them to try 2 or 3 or 4 different ways. We want them to get the way done, get the data right. Okay? To me, there's 2 things as developers. Number 1, get the data right. Absolutely number 1. Number 2, get it back as fast as you can. And a lot of shops is get the data right, get your sign off, and then give it to a DBA, let them figure out if it's going to run fast enough or not. I think that's a developer role. Okay, as a developer, I think we should be responsible for a big part of that. So that's what this presentation is one piece of this, that we're going to go through a lot of examples. We're going to talk about some standards, some guidelines, and some things that hopefully you have some great examples to take away from this presentation, and some things on optimization, performance, and tuning, and hopefully leave a little more empowered than when you walked in the door. All right? Any DBAs in here? Okay. We have, this is kind of cross-platform. So this, whether you're on ZOS or whether you're on LUW, I mean, this kind of stuff, Oracle, SQL Server, Sybase, you name it, relational database system. And usually in a lot of these companies, they have like 3 of them, SQL Server, Oracle, and DB2. Sometimes 4 of them, DB2, both platforms, Oracle, SQL Server. So we tend to bounce around on some of these different relational database systems. So it really kind of fits across the board. Okay? So hopefully you're going to get a little stronger in SQL, understand the power of rewriting things different ways, a little more educated in the area of performance and tuning from the application side. Hopefully you're going to understand how certain statements operate. We're going to look at some statements and we're going to talk about what goes on behind the scenes. So you kind of get a better feel by rewriting it a different way, how physically things can happen differently to bring back the same result set. So we'll talk a little bit about behind the scenes. Different areas of performance tuning when it comes to a program query, and we'll break down mainly the different predicate types and how they affect query optimization. And the biggest thing to me is get empowered. I'm all about getting developers more educated, more empowered, changing the culture of some development areas in companies. Getting them more empowered. It brings morale up. They feel better. They're getting stronger at SQL. There's nothing more fun than getting something that runs an hour and getting it to run in 20 seconds. That's a great feeling. And there's a lot of things that we're going to talk about. A lot of it is not that hard. Some of it gets pretty involved, and you may need some DBAs to help us out. But most of it is actually, I think, pretty simple. There's a lot of things that can affect queries and programs from running a long time in DB2, and these are some of the obvious ones. Okay, what can we do? What can we look at? What roads do we go down? I have a query or a program. It's not running very good. What do I do? Where do I start? Okay. Well, one of the things that we're going to concentrate on is in this presentation is this right here. So there's a lot of developers that are out there. They've never run an explain, or they run explains. They don't know how to read to explain. If you run an explain, it's going to tell you what's going on physically behind the scenes in retrieving your data. So without even knowing how to do an explain, I mean, oftentimes I just tell developers, if you can think of a different way to write your query, if you can think of a different way to write a predicate or two in your SQL statement, you'll be amazed sometimes where all of a sudden things run differently. Without even knowing what's going on behind the scenes, if you can just think of another way to rewrite it. So when I talk about a predicate, I'm talking about statements in your where clause, where last name equals Andrews, that's a predicate, and department number is in, that's a predicate, and each one of those is called a predicate. So if you can think of a different way to even write a predicate, sometimes things will drastically change. Okay? Redesign the program flow. So this is what we're going to concentrate a lot of examples on today. Redesign the program flow. I'm going to touch on that a little bit more as we move along on how I call it procedural coding versus relational coding. And I'll hit on that a little bit off and on throughout the presentation. Statistics, changing the physical design, system tuning, or some other areas that can affect performance. We're not going to hit any of those in this presentation. We're going to concentrate on this, a little bit of this. The only thing I'll say about the physical design that I tend to find often out there, and we as developers and DBAs need to think about this a little bit more. I see so many tables that are in primary key physical order. That means on page 1, offset 1, there's key number 1, key number 2, key number 3, 4, 5, 6, the next page, and that's the order of the data physically sitting in the file. Now we can control that. So how should the data be physically in the file? Yeah, you got to know your application a little bit. You got to know the queries. How's the tables getting queried most often, gathering up these larger amounts of data. If I got a bunch of queries that are bringing 1 or 2 rows back at a time, I don't even pay attention to those because I'm bringing back 1 or 2 rows. What about the queries that are bringing back hundreds or thousands or tens of thousands or maybe like 20 million rows? The way the data is physically clustered has a huge impact on performance. So So let me go forward here, and here's a little bit of the tables that we're going to see coming up here in the SQL that I have in this presentation. And these come from the set of sample tables that every DB2 shop has. They've been around forever. There's the employee, the department, the project, the project activity table. So here's a little bit of the department. I call it a master table. Here's the employee table. Okay, the employees, their numbers, primary key. The department, their last name, first name, salary, bonus, a bunch of other columns there. So in the employee table, currently, it's in employee number order. So when you come in and you say where department number, I want to select from this table where department number equals A00, where are the A00s in that physical file? They're scattered, okay? So when I get into some of these applications and I get to looking at some of this stuff, and I start seeing a lot of aggregations, mins, maxes, average, sums, by department. I see a lot of reports by department. I see a lot of joining. Most of the joins to this table is by department. That's a flag to me. That table should be in department number order. Okay? The problem is, once these things get into production, and they're in some primary key order, to get them to pull it out of production, recluster, and you got to retest everything. Got to get 40,000 sign-off. It becomes a big project. So it's almost impossible to do that unless there's some real pain going on. Okay? So it's just something on the physical side. My only one comment is think about this as new tables are getting created that you're working on. Primary key just seems to be so common. And in my experience, a lot of the tables should not be in primary key order. I don't gather big groups of data by primary key ranges. I grab them by date ranges or some other kind of ranges that we need to pay attention to. It can kill performance. It can be hours versus minutes, minutes versus seconds kind of response time. because there's more like get all over the physical file to come up. If there's 100 people at A00, those 100 people could be on 100 different pages in the physical file, could be 100 get pages to bring back 100 rows.
Death by random I/O.
Yeah, death by random I/O. Great phrase. Yeah.
It doesn't mean whether there is an index for department number or not.
Well, the way you define the clustering order of a table is by one of the index definitions, so that when they do loads and reorgs, DB2 knows how to resort and load the data back in the physical file. Okay. So there's a little bit of our employee table. Here's an employee project activity table, one of the DB2 sample tables that everybody has, no matter what platform you're on. And this is just partial data, so it lists employee numbers, the projects that they're on, the activities they're on, the start date, end date, amount of time they put, for that particular activity. So you can see here, employee 140 happens to be in here numerous times, and that person could be working on different projects, could be working on different activities of the same project. So the relationship between the employee master in this activity table is a 0 to many. We could have some employees, they're not working on anything. So they don't have a row in this table. Okay, so that's the relationship going on there. Okay, so let's start with our first example here. Provide a report of employees who work on project IF 2000. So who out of the master table has an employee number over on this activity table with project IF 2000? So it's kind of exists logic. Who here exists over on that table under IF 2000? So this kind of, some employees may not be working on projects that, that 0 to many relationship. So we have two tables that we have to have in our query here. The master table and our activity table. So the first thing we can think about doing is writing a two-table join. Let's just join the two tables, empno equal empno and project number equal IF 2000. Okay, so when we run that join, it's a 0 to many relationship. So the possibility of something like this could occur. Okay, so we get Nichols, employee 140, comes out 4 times, and why is that? Because if I go back and I look at the data, that 0 to many, 140 is down here many times, and they're actually down here many times for IF 2000. They're also working on a different project. So in the join, we get duplicates out. Now what a developer is going to do 99% of the time? Distinct. Man, developers are distinct happy. They love distinct. They coded just in case. Okay? This is where walkthroughs come in. I'm really big on walkthroughs. Okay? Where when I see joins, I'm going to look at the developer and I'm going to ask them, what's the relationship between these tables that you're joining? If you have one here, well, you'll always have one here. If you have one here, can you have more than one here? Tell me the relationship, because that's going to dictate the possibility of them getting duplicates. Maybe they're not getting now, but they get duplicates in production and an incident report gets created. Or they're doing an inner join where they should be doing an outer join because they want the exceptions. They get the wrong join type, runs in production for 3 or 4 months, an incident report gets created because now there's some duplicates that come out. And the developer goes, don't look at me, I haven't touched that code in 3 months. Okay? And it all stems from development. Understanding and knowing your data, knowing the relationships. So you can write a two-table join. We get the duplicate to say, I don't want the duplicates. I just want a list of the people who are working on that project. So they come back in. They put the distinct in. Okay. You can also do a group by. I don't know if I have a group by. Yeah, I can also do a group by here. Would do the same thing. We get rid of the duplicates. Oftentimes, distinct and group by causes sorts. Sometimes group by and distinct does not cause a sort. If it's not causing a sort, then that could be a really good thing. Then in this particular situation, DB2 has a few different join methods that it could go through and to bring the data back and handle the duplicates without a sort. So how do I know if there's a sort going on? Well, you don't unless you do and explain. Okay? Sometimes there will be, sometimes there won't be. Another way we can get this piece of logic, I'm going to back up here. So we have this table, emp project activity table. We need this in our query, but I'm not pulling any data from it. I need it for logic, but I'm not pulling any data from it. That gives me some options as a developer. I can take that and I can put it down to a subquery. When I put it down to a subquery, I have a couple of different subqueries I can put that in. One's called non-correlated. The next one's going to be called correlated. So this is an in. Give me a list of the employees who are in this list of employees under IF 2000. Okay? Now, when you get to in and exist logic, you're not going to get duplicates. You know, am I in that list of employees? I could be in that list 40,000 times, but I don't see it 40,000 times back. Yeah, I'm in that list, period. Do I exist down in that table under this join method that we're going to see? I could exist down there 40,000 times, but I don't see it come out 40,000 times. You get the duplicates on the join. You don't get the duplicates with the in and the exist. So you don't have to worry about the duplicates. So when you run an in, this in, non-correlated, this thing's going to execute. It's going to build either a list of values here for this predicate. And what it does now, as of like version 9, sometimes it puts these values in a little temporary table and it does a join to this table. And you'll see that in the explain. It gives you some funky little table name, you know, DSN, work file, QB2, because it's Q block 2 in the explain for those of you that have done some explains. Okay? The other way we could go about this is we could do exist. Okay? When you do exist or not exist logic, you have a join predicate down here. So in this case, this subquery is going to get executed a whole bunch of times. How many times? Well, depends what's coming out based on our where logic up here. If there's 1,000 rows in our employee table, this is my only filtering logic, this thing's going to get executed 1,000 times. You go, well, wow, wouldn't that subquery that executes once be a lot faster than one that executes 1,000 times? The answer is no, not always. Okay? There's a lot of it depends that kind of comes into play. The point is we're seeing some multiple ways to get this. Is pretty common logic I find in development. I want to know what is here that exists over in that table. Okay? So we're seeing some multiple ways to do this. So one of the things that I'm real big on projects too is getting a document out there on a share drive and say, look, if you ever need to write some code where you're looking at one table to see if the primary keys exist in another table, here's 4 ways to do it. Try all 4 before we go to production. Try all 4 before you come into a walkthrough, if you guys do walkthroughs. Find the one that runs the best. What everybody typically wants to ask, well, just tell me which one's the best. Well, that'd be nice if we could always just say this one's always the best, but there's not always. It depends. Sometimes this will outperform the in will outperform the exist. The 2-table join could outperform both of these. Depends on indexes, depends on clustering, depends on if there's any sorts going on. There's a lot of depends there. But for developers, this to me is pretty easy. We got to join, watch out for duplicates. We want to make sure we can have duplicates. I mean, I've seen code and I've had meetings with people and they say, I got distinct in every join that I write, just in case we get duplicates. And I go, no. We don't go to production with code just in case. We go to production with code when we know exactly what's going to happen. We know exactly what the data is. Because if we code generally like that, generically, then we get some performance issues. Okay, so let's know exactly what's going on. Especially, so anytime you ever write a join, you should be thinking automatically, what's the relationship between these tables? And that's going to drive you down some certain avenues. And if I have a row here that may not be over in this, what do they want in the output? Do they only want the rows that exist in that table, or do they want the rows that exist and the ones that don't exist? That's when you get into the outer joins. So knowing the relationship between the table and knowing what we want for our output is going to dictate what join we write. I see so many incident reports because they got the wrong join in production. But they've been running in production for 3 or 4 or 5 or 6 or 7 months, and data changes. Because when they first went to production for 4 or 5 or 6 months, the data was perfect. It fit an inner or an outer join. You got the same rows back. But then data changed, and all of a sudden the user goes, hey, wait a minute, I'm missing some of my data. We just added a whole bunch of data the other day, and I'm not seeing it on my report. Well, they should have known that from the very start and had an outer join, and we're covered. Never have to go back to it. Okay. So this is a third way to do it. This is a way that goes back. This is kind of old school here. This is like not good, but I still see this sometimes out there, where developers will come in and they'll say where 0 is less than, and they'll do a count down here. And they'll see if 0 is less than a count that comes out of here, that means that employee, what are we talking about, existed down on that table for that project. Okay. So that count would come out. So if the count comes out greater than 0, they're down on that table. But what if my logic down here? What if I got 1,000 rows down there? That could be 1,000 get pages to come up with a count to see if it even exists down there or not. That's not good. So this is one of them. I would say, you ever see one like this? Rewrite it, okay? Because I've never seen that outperform any of the other ways. All right? I still come across that once in a while. In fact, Terry Purcell asked me about that a couple of IDUGs ago. He goes, really, you see that once in a while? Should we do something on the optimization side? I go, yeah, you should. Did you? Yeah. When it came to version 9, we had this Intersect that came about. There's another way you can find some rows on one table that are on another table under pieces of logic. Okay? Code it up like a union or a union all. This is another way to do it, where you got a common table expression here, then you're coming and you're doing a query here, you know, against the master table because we want to get some columns from the master table. We have some other examples with the common table expressions coming up here too. That's if you're not familiar with the common table expression or nested table expression, hopefully you'll get a little bit out of this presentation and have something, you know, to go with, because at times it can be really powerful. It gives us another way. Sometimes it's like the only way to get the logic that we want to get out of a query. So here's a little summary of, you know, as I walk through each of these, we talk a little bit about what's going on behind the scenes. So the interesting thing to highlight here is oftentimes by rewriting a query a different way to get the same results causes different physical things to happen behind the scenes. Well, if things are happening differently physically behind the scenes to bring the data back, one way is going to be faster than another way. So I tell the developers, like, let's try them. And if they get confused about it, let's put them out there on a document. Say, look, you got ways out there. Look at the document. Go through those ways before you go to production or come through a walkthrough. Are there any walkthroughs going on in your shops? Yeah? Is anybody? I mean, I get in some shops sometimes and they go, no, we don't have time for walkthroughs. I mean, management states we don't have time for walkthroughs. I go, really? I go, what's different today than when I was on these big projects? They go, oh, we got so much going on. Everything's got to be done by last Tuesday. I go, well, you know what? I was on projects. Everything had to be done a couple of Tuesdays to go all the time. And we did walkthroughs, and we did explains, and we did all this stuff, and we still made it by 2 Tuesdays ago. So I hear this like often, so I always like to ask that because I find it absolutely amazing. That's how I got really good at this stuff, by going through walkthroughs. Man, people tell me, give me some other ideas. Is there anything you see wrong? Can I do something better? Can I rewrite something differently to get something to run faster? Because the more stuff we get to run faster, the less IT costs we have, CPU cost. So we want to get things as efficient. That's the second thing in my list of developer duties. 1, get the data right. 2, get it back as fast as you can. So in a lot of developers out there, and there's millions of them today worldwide, I find that a lot of the developers are not very strong in SQL programming. Okay? Walkthroughs, mentorship. This comes from the application management side. So I'm like big on them, and I don't really care what management says. We don't have time for them, so no. We'll make time and we'll still get the date, okay? Because it's just huge. So here's something from the mainframe side. How many LUW people are in here? Okay, I have a few screenshots like this, and you can kind of get the same thing on the LUW side, where one of the things when you do explains, the optimizer will provide some costing, okay, guesstimates. It's a guesstimate costing. And on the LUW side, you get all kinds of costing numbers, okay? So it doesn't necessarily mean that the one with the lower cost is always going to run better. It's a guesstimate, okay? But it's a pretty good guideline. The only reason I wanted to show a couple of these throughout the presentation is to show you we're seeing some different numbers here. We'll see in different numbers, the optimizer is realizing it's got to do things differently physically. Because it's doing things differently physically, it's going to come up with different cost. Okay? If it's got to do something one way or something another way, it takes that into account. What's it have to do to get the data this way or this way, and it puts cost associated with it. So putting some of these costs like this and see that the difference in the costing, kind of is just a way to prove that there are things differently going on. So the interesting thing here is we have these three have the same costing. So this is on the mainframe side. Back on the mainframe side in version 9, they came up with something called correlation decorrelation. So what they're trying to do with the optimizer is trying to get it as smart as we are when it comes to rewriting things different ways. So one of the ways that the optimizer will do now on the ZOS side is it will take some correlated subqueries, and it will then rewrite it as a non-correlated subquery in the optimizer code, and then cost out each of them. And sometimes it will change this to a non-correlated or a non-correlated to a correlated. Okay? Kind of interesting. Now, how do I know it ever did that? Okay, look and explain. There's a subquery type. It'll say correlated or non-correlated. So this could be a correlated, and I see it at what says non-correlated in the explain output. Okay. So the interesting thing is, I could take a non-correlated, and I see the optimizer writes it as a correlated. So I come in with this one, and I see that the optimizer rewrote it as that one. Okay. Okay, that's good. So I go and I write that in my code, and I go through my explain. And when they take this, the optimizer then takes this and writes it as a two-table join. Wow, that's interesting. So I go from non-correlated, the optimizer sometimes takes it to a correlated. But then if I give it a correlated, sometimes it takes it to a join. Well, why didn't it take from the non-correlated to the join? It's just not built in there, not built in the optimizer yet. It's kind of like one step at a time. So sometimes it will rewrite it a different way, and sometimes it won't. So as developers, we should still try every single way, okay? Because as I send in a correlated, let me go forward. As I send in a correlated, okay, it may write it as a join, but if I write it as a non-correlated, it won't take it to a join. Okay, so we still need to rewrite things different ways.
Very release dependent.
Yeah, very release dependent. Okay, so
change when you go from 9 to 10 to 11.
Yeah, that's right. It could, you go and you re-optimize going from version 9 to version 10 to version 11. Things could change again. So as developers, I still think, and we should push, try all these different ways, and then pick the one that runs the best. Okay, here's another example here. Provide a list of employees that major in both math and computer science. Pretty common table design. This is not one of the sets of tables in this. One of the tables in the set of sample tables that come with DB2. But oftentimes we have a primary key that goes a couple of columns. Okay. So I want to find a list of the employees that have a row in the table with this MAT and a row in the table that has CSI. So E1 is going to fit that. E2 is not, E3 is not, E4 is not. And E1 could even have some other ones. Maybe they got 4 or 5 different majors. But they have one of math and one of computer science. How do I find those? How do I get to that? I find this pretty common table design. So let's take a look. So one of the ways we can do it is we can come in, put our where logic in here. Give me the rows that have an MAT or a CSI. Group them up. And if the groups have a count of 2, what's that telling me? They have both of them. If they don't have a count of 2, they didn't have both of them. So we're doing a group by with a halving. So those of you that may not be familiar with that, the group by executes first. It's kind of a 2-step process. The group by executes first, and just a regular, each employee is going to have a count along with it. And then the halving clause puts logic against the groups. It's like a where clause after the grouping. Because in the where clause, you can't say where count star equals something, or where average salary, or where min hire date, or something like that. Those aggregate functions can only be used in the select and the halving clause. Okay? So that's one way to get that logic. Another way is something called quota query, okay? Where you come in with a number, where 2 equals select count, and this kind of goes sort of against a lot of things I was talking about a little minute ago with the account star, but it's another way. So logically, we have a correlated subquery down here, and we're checking to see the count equal to 2. So when you see a correlated subquery, when you see a join down here in this subquery, that thing's going to get executed a number of times. It's like a join. It's feeding the values, feed a value, feed a value, and the values are coming from up here. And we got the distinct up there too. My guess would be that was probably not going to be one of the better ones, ways to get this back. Okay? Another way we do it is called a self-join. Very common. We put the table in there twice. There's a lot of different times in SQL programming where you may see or need to have the table in there twice to get to the logic that you want. So you list the table twice, you give it 2 different correlation IDs. Okay? And you join the 2, where the employee number on the one table equals the employee number on the other table. Well, of course, the employee number is always going to be equal on the other table, right? But on the one table, it's MAT, and on the other table, it's CSI. It's not really physically another table, but that's the way I like to visualize it. I mean, I like to think of that. I have that table out there twice. Here it is. I do employee equals employee. I got MAT over here. Do I have a CSI over here for that employee number? Let's go to the next one. Got an MAT over here. Do I have a CSI over here? And that's the way I like to kind of visualize it. I mean, DB2 doesn't go and make a copy of the table or anything like that behind the scenes. It's called a self-join. There's a lot of times with self-joins, we have to have the table in there twice to get to the logic that we need. So if you ever come across some and you see a table in there twice and you think, oh my gosh, what are they doing? There's usually a pretty good reason for it logically to get the result set that they're looking for. Now what will happen oftentimes in developer code, and this is where we go back to one of the bullets I said I would bring up a little bit off and on during the presentation, is program design. Okay? So I can tell you what a lot of programmers do. They code very procedurally. So they'll get a cursor, or they'll write a query that's going to bring back all the rows that have major and math, and then they might branch off and do another separate query at the same table for that employee number and see if it's a CSI and see if they get a 0 or plus 100 back. Then they get the next employee. Then they go do another separate query. They get the next row over here and do a separate query. And they're splitting their logic out into separate queries. And when you split your logic out into these separate queries, what's going on? You're sending a lot more statements to DB2. So in programming, in batch programming, besides like poorly written SQL statements that just, you look at the explains are just not very good, the number one reason why these batch jobs may run 6 hours on a Friday night, there's too much back and forth and back and forth and back and forth between their program and sending SQL statements to DB2. So I talk about redesigning program flow. So developers code very procedurally. I mean, we all got these logic brains, and it's step by step by step by step. And I get in so many programs where they'll like take a COBOL program where they get a cursor. And for every row that they get, then they go perform, let's see if it exists here, let's perform, get a description over here, let's perform this, then come back and get the next row. And then perform. So every row that they get here, they're doing 4 more trips to DB2, going from their code to DB2. So whatever their code's written in, SQL's got to run in DB2. SQL can't run in a COBOL environment. SQL can't run in a Java environment. It's got to run in DB2. So there's the passing of the SQL statement over to DB2. There's some overhead incurred there. Okay? So if we can take that logic and make it a 3 or 4 table join and minimize this number of back and forths, I guarantee it's going to run faster. And this is like in programming, when I'm on projects, I want to see counts come out of batch jobs. I want to see how many open cursors, closed cursors, selects, fetches, updates, inserts, deletes. I want to see counts on everything. Because I get into some programs sometimes and I'll see the count 485,000 times they've gone back and forth and back and forth and back and forth between their program and DB2. So my first thought is, okay, what can I do to minimize that? And a lot of programmers aren't strong enough to do 2 or 3 or 4 table joins, or a 2 table joins with an exist, or something like or a common table expression or whatever. So they just step their way through it. They get the results that they want, but it kills performance. Okay. I'll show you some other examples along that line too. So there's a self join. So there was a couple of different ways. That way is probably not going to be as efficient. But we have the group by and the having, and we have the self-join. A couple of ways to find those rows in a table design of that. It looks like that. Okay. How about this one? Find the youngest employee in each department. The youngest employee would be the one that has the max hire date, the max birth date, not hire date. Okay? So you have in each department in our employee table, you got, 10, 20, 30, 40 people per department. You got all these departments, across the data. So I want a listing of each department and who's the youngest one in each department. So how do we get that? Well, here's one way where we go into a correlated subquery. Okay? So where the birth date equals, select the max birth date, and we're joining on department number. So if we start, the logic starts up here and it feeds the subquery. Okay, there's a join down there. It works just like a join. So you start at employee number 10 up here. I happen to know in the data it belongs to A00 department. So it starts up here, it passes A00 down to here. That query runs, finds the max birth date for everybody in A00, and sees if their individual birth date equals the max that it was calculated. Then it goes to the next row. Employee number 20, part of B01, passes B01 down here. Calculates the max for that, checks their individual to that aggregated, and it keeps going and going and going. Now the nice thing is, if there's 100 people that are part of A00, this does not get executed 100 times. Okay, the first A0 that comes down here, it calculated the max birth date, it stores that in an in-memory table. So that the other 99 people, when their A00 gets passed down to here, the processing code goes, I've already calculated for that value. And it just pulls it from the in-memory table and compares it to the individual. So if I have 100 people that are part of A00, this gathering of all these rows and figuring out the max only happens one time. And then it stores it. Yeah?
What if you go to the data that's changing?
What if what?
What if your data's changing?
Oh, during the running of your query? Well, it may once you start at that point in time, it's not going to recalculate. So if there were some other rows that are added during that time, then
Also depend on your isolation level, whether you're going to be allowed to change the data while you're running.
yeah, that's true. Yeah, so if you're concerned about that or not concerned, there's some isolation levels in the binding of that query or program that can control that. Yeah, that's a great question. I mean, there could be. I mean, there's sometimes there's action going on all the time, all day long. Yeah. So when this thing kicked off at that point in time, this was the output. Somebody else have a question?
In the development region, we are generally using tables on which we have production statistics published, but there's no data in it, and that has been our practice for a long time. And our explains are run on that table set with production stats on it.
Okay.
Is there anything we need to do to improve the accuracy, or is that a good method?
Yeah, put more data in there. Yeah, so did the tables have any data at all?
They do.
They do have some data.
Volumes are very, very low compared to.
Yeah.
But production stats.
Production statistics, but not production data in your test environment. That's a tough one, okay? Because in my experience, I can look at a couple of different explains, and the explains they both look like pretty good, okay? If I write it up a couple of different ways. But if I need to have enough data that can show me the differences in runtime, okay? If I got 1,000, 2,000, 5,000, 10, 15,000 rows, it's all going to come back just like that. I need a few million rows in those tables, okay? So that when I run one versus the other, I can actually see a CPU difference. And I see that the optimization changed, but now I have to go test. So the key to that is we rewrite, we re-explain. Yeah, it did change, or maybe we're not explained, but we rewrite and we retest, and we're looking at CPU differences between the original and the rewrite.
Other than the CPU differences, how good is the estimate, RDMS and process can we just take it because the volumes adding more volumes is not an option for it. It's not.
Yeah, so it's a guesstimate from DB2. So my comments on that is look, they're not going to put more data in there. We don't have much more data in there. So if you do some rewrites, then really we have no choice but to go with the guesstimate. Okay, that's what I suggest. Go with the guesstimate, but then you run a risk because we've all been involved in ones where the cost is lower, but it runs worse. So that's the risk. And they need to know that that's a risk. Say, here's what I did. I tried 2 or 3 different ways. In this environment, I've got production stats. This was the lowest cost. I don't know what else I can go by. Because if I rerun any of them, they all come back in about the same amount of CPU because there's hardly any data there. Yeah, great question. That's a problem in a lot of shops. So my comment in meetings then is, look, I know you can't copy everything down there, but copy 5 million rows. I mean, 5 million rows can copy just like that. I mean, come on, get us some data in there so when we can do rewrites, we can see a difference in runtime. 5 million rows, you'll see a difference in runtime, CPU. And then you go with one with the lower CPU. And just hope that that's still going to, that there still could be a change in production because it's so much bigger and partitioning and all that kind of stuff. You could possibly still not be the exact perfect one going into production. Yeah, right. Yeah, privacy data. Yeah, they whatever they're, what's that? Yeah. Yeah, I think kind of what she was referring to, like bringing the production statistics. Yeah, you have all the cardinalities, they're out there in the high 2, low 2, high 2 key, low 2 key. All right, so this is one way to find the person in each department that is the youngest. So here's another way, okay? It's called a RollValue expression. So in our where clause, we say where the department and the birth date for each individual row is in this list over here, okay? So I have 2 values here, I put 2 values over here. They have to like match up. So when this thing runs, let's just say it runs and it builds an in list, okay? So when it builds the in list, it's going to be 2 values, comma, 2 values, comma, 2 values, comma, 2 values. And every row here is going to look at each row is going to look at and say, are these 2 values, do they match one of those sets of 2 values that was built in this in list here? Okay. So we have a group by over here, max, department, and then so this is like a 2-step process. So this thing's going to run. It's either going to build the in list or it puts it in a temporary table. Okay, we see both of those in DB2 anymore. And then it's going to go through these rows. In this case, there is no other where logic, so it's going to look at every single row in that table to see if this combination is in that list. Let me back up here. That's far different than this. But we get the same results. But it's far different in the processing behind the scenes. That's the key to me. That's why I think developers need to get a little bit stronger in SQL. We need to document things out there on how to get solutions and get them stronger, because sometimes this can be massively amount of difference in runtime. There's a couple of different costings here on those. Look at this query number 501. Very high cost compared to the other one according to DB2. If I come back to this one, this happened to be the 501, where it's got this correlated subquery in here. So my guess is the reason that has such a high cost is this feeds this. You send a department number, and the first employee sends a department number down here, and it's got to figure out the max birth date based on A00. Let's say we'll just start there. Where are all the rows of A00 in the table? They're all over the place. DB2 knows what the order of the tables are. So it's going to go get these 100 rows, figure out the max, and then we go to the next employee. Go to the next employee, go to the next employee. By the time this query runs, we will have hit every single page in that table. Okay? I think the optimizers are smart enough to realize that, because we're going by department number. The table is not in department number order. Okay? Much higher cost. Some people say, yeah, but it's got a group by, and that always typically causes a sort, It does. But sorts are pretty fast in DB2, okay? I mean, if we can eliminate sorts, eliminate them, okay? My statement is sorts are as expensive as their size, okay? So when I often see a group by or often see some kind of order by or something in somebody's query, my first question to the developer is, how many rows are going into this sort? How many rows typically come out in our result set? There's only 100, and we only have 100 row sort. That's going to happen just like that in DB2. Is it 100 rows that come out? Is it 100 million rows coming out? Okay. Okay, here's one. List of departments where a department average bonus is greater than this department average salary. The average bonus is greater than the average salary. Man, that's my department. That'd be like, I don't care what you do over there. I'm an expert at what you do in that department. So this is kind of another thing that sometimes I get in some applications and I start seeing a bunch of aggregations on a certain table. And that just sort of raises the flag to me. Like, you know what? Maybe we should have an aggregated table out there. And let's just keep that thing updated like during the day. Or an MQT that we refresh once in a while. Whatever we can do. That way I have a physical table that has these things calculated. I mean, these things aren't being like generated and get page and calculate these off and on all day long through all these queries running during the day and at nighttime in batch. So here's one. We don't have these aggregates stored anywhere, so we're going to calculate it by department. So same thing. It's going to start up here. It's going to feed the department number here. It's going to go against the employee table. Get it up all for A00, get the average bonus, feed A00 down to here, calculate, compare the two, go to the next one. Go to the next one, go to the next one, go to the next one, go to the next one. Okay? How about this one? There's another way to get this. This is kind of a good one here where we have having. I said we can use this in a select and a having clause. You can't say where average salary, where count star. You can't use these. They call them aggregate, and they also call them column functions. The min, the max, the average, sum, and the count. But we can, however, use them in the having. Okay, so we're having, give me the departments that have a bonus greater than a calculated average salary down here based on this join. So we have subquery as part of our having logic. We've often seen some queries that are part of our where logic. Okay? This is where logic on the groups. Where is where logic on the individual detail rows. So that's another way to get this solution. Here's another way we can get it. Okay? I don't have a table that has these aggregations by department. So you know what? Let's build it. Let's build it. I hear that often, like, well, we don't have a table with that. We have the power to create any table that we want. And we can create it for the duration of the query, or we can put it in a global temp table and have it for the duration of our program run. Okay? We can derive whatever table we want as programmers and put it in a temporary table. We have that power. We don't need authorization. We can do it. Okay? And that's what this common table expression is all about. Or nested table expression if you put it down in the from. So let's just go ahead and let's just real quickly, or as quickly as DB2 will do it, let's go get by department average bonus and average salary. Group it. So it's going to go after this table, go through everything, probably have a sort there, aggregate, build us a table. This table is called X. You can call it whatever you want. I think maybe you can call it up to 128 characters probably. That's your actual table names. I tend to give my correlation IDs and things like this much smaller because, the more I type, the more syntax errors you create. So there's a table that will be created called X, and then it becomes a two-table join between your detail table and your aggregate table. Beautiful. Now, what if we already had that table out there? Then I don't need to build it on the fly. That's runtime. So if I have a table of average bonus, average salary, some of this, some of that, min of that, max count, and it's all out there, and we just kind of update it off and on during the day as detail changes, that's awesome. Then this kind of stuff is not happening during runtime, during the day at night. If you can do that, yeah.
So what if instead of that you do a view? Like you're going to use it quite often, so one table.
Okay. So you take this aggregate right here, he said, how about we put that in a view? So when you say create view, we'll call it empv1 as, and then you have this select right here. Okay. So when you create the view, let's think about what happens. When you run that create view in a query tool, it's going to come back and say create successful. Okay. What'd you do? Yeah, what went on? Well, what it did is it took the view name empv1 and it put it into systables. So anything that a DBA creates or anything that a DBA alters in their DDL statements automatically gets logged in some of the sys-IBM tables. Sys-IBM.sys-table, sys-IBM.sys-column, sys-views, sys-indexes, sys-foreign keys, on and on and on and on. So the name, the v1 name, goes into the sys-tables. This SQL statement here goes into sys-views. So when you come in with a query then and you have a view name in here, the first thing DB2 always does when it receives a query is it grabs your from statement and it goes and looks it up. What do I know about these tables? So it's going to look up that MV1. It's going to go, oh, that's a view because it has a type V in there. Well, I better go over here to sysibm.sysviews and grab that SQL statement and execute that. So is it really buying us anything? No. It's a shortcut name to the query here. That's all it is.
Pretty much, so like instead of having that with X in 1,000 programs, you just have it that code repeated instead of having to change it to 1,000 programs.
That's one good reason for a view. Absolutely. Yeah. And then there are some places and purposes. That's a perfect one right there. Yeah.
I've seen people, I'm sorry.
That's okay. Go ahead.
I've seen people
Ooh.
create views which are exactly the same as the table. So it has exact same columns and there's no where clause. So the whole table is just very
Okay, I'm gonna, yeah. Talk to David. He's very experienced DBA. He can feed that back to you a little bit. There is no advantage. He can tell you a little bit. We got 10 minutes left, so I'll tell you what. He'll spend a couple minutes after the class, and but the key to that is there's no advantage. Okay, all right.
But lots of people do it.
But lots of people do it. Okay. So anyway, this is kind of an explain of all those ones that I just went through in this last one, find the youngest employee of each department. And, we see like different access types. And look at this here, the table name, X. So this goes back to when you write a common table or a nested table expression, sometimes those expressions get what we call materialized. Means that DB2 is actually going to execute that query and put it in a physical work file. But sometimes it doesn't. If you're not doing any kind of sorting or grouping, it can just merge that logic in, even though I had it coded as a common table expression, and it will merge it in with the logic down below. So how do I know if it's materializing or not? You don't until you go to an explain, and if you see the table name that you gave it in your expression, that's DB2's way of telling you there's materialization done. That thing was executed and it was put into a work file. Okay? That's kind of good to know sometimes, because if you build a work file like this, and it does get materialized, let's say it put in 120 million rows, and you're joining it to another table. Well, that 120 million row temp file doesn't have any indexes on it, so the join process may not be that well, may not perform that well. But if it's a smaller one that got materialized, then I don't worry too much about the join process because it doesn't have that many rows in it. So when I see something like this in an explain, my first thought, just like sorts, is like, what's going in there? How many rows are going into that X table? I'd be curious about that. Is it 100 rows? Is it 150 million rows? And it's amazing when you get with developers and you go through some walkthroughs and you ask these questions, you know what the typical answer is? I don't know. Or they'll say, I don't know because we don't have the same amount of data that we have in production. That's very common too. So right now in test, we get 8,000 rows in that. When we go to production, I don't know. I can't run queries in production. We don't have that data. I don't know if it's going to get 180 or it's going to get 80 million. Makes it a little bit tougher. Okay, so there's some different costing there that we see. Okay, got about 10 minutes left here. Not logic. Okay, so just the opposite of where I started. Find me the rows here that do not exist in another table. We've got 3 ways to do that in SQL. You can do a not in, okay? The not in you have to watch out for. If this is a field that's defined as nullable, then you need to add where that column is not null. Or DB2 will put that null as part of the list, which becomes what's called an unknown, and that means that none of these rows will actually not come out. It'll run, but you won't get any rows back. Okay? This is a real gotcha. I've seen a lot of these in production incident reports, where all of a sudden, somebody goes, hey, Tony, you want to come to this meeting? We got this job. It's been running every night for the last year, and now all of a sudden it got no data out. Because all of a sudden somebody came in and set an employee number to nulls. And that nulls became part of the not in list, and nothing comes out. That's a real gotcha. So anyway, we got not in, not exist. Same code exact way as the exist, operates very differently. The other way is what we call an anti-join, where we say we take the driver table, we left join it to the mproj activity table. In outer join, this is the driver, this is called the null supplying table. Because in the process of this join, they'll take an employee number, they'll take it over to the mproj activity table and go, oh, then it's not over here. So what comes back from that table on any column that you reference? Nulls. Because DB2 goes, it wasn't over there. I can't send you anything back. So if I say if all you find is a null over there on what we're joining, that means it didn't exist over there. 3 ways, okay? Document them, put them out there, okay? And tell the developers, try all 3 ways. Now I can tell you in my personal experience, the not in has never outperformed the other 2. But I don't ever want to discount it totally. But you got 3 ways there. Okay, and there's some explain, some costing. Okay, max date row, just real quick. Oftentimes we have multiple rows that in our current table, and I always want to get the most current one. And they're differentiated by when the row was added by a date field or a timestamp field. So we have 2 different ways to get that. Okay, this is the most common way, not always the most efficient way. Wells Fargo down in St. Louis, they use this like all over the place, and it has totally outperformed this way in a lot of their situations. So we have 2 ways to find that piece of logic. Most of the time, that's the only way that people know. Okay, so that one's another one. That's a big discussion there. I'm going to run out of time here. Okay, so here we go. Thanks for allowing me to share some information with you. Hope you learned something new today. Okay, hope you're a little more inspired. Okay, and I love this. I've been on a lot of big projects. Standards, guidelines, documents out there, educating the developers. Incident reporting is low. It's amazing, absolutely amazing. And I get in so many shops, or I talk to application managers, go, we don't have time for that. I go, well, I don't know. If I'm running the project, there'll be time for that. Absolutely. You know, if we have to put an extra 5 or 10 hours a weekend, we put an extra 5 or 10 hours a weekend. But we're going to go to production with the best that we have done, and that's trying out a lot of these different things and doing explains and such. So, session E07. Hope you guys are all empowered leaving here today. Learned something new. My email, if you guys ever have any questions on stuff, feel free. The nice thing is, if I don't know the answer, I typically know people that know the answers. Like David Simpson's one of them right here. A few others like hanging around. So, yeah, feel free to email me. All right? Thanks for coming. Appreciate it.